Hello everyone, in this video we will be discussing the third case of the technique in evaluating improper integral with infinite limits. So this case is just the combination of the first two cases that we've discussed. So we have here if f is continuous for all x and if the following limits exist. So the first one is case 2, while this one is case 1. Okay, then the improper integral given by this, the integral of f of x dx from negative infinity to positive infinity is equal to the limit of the integral of f of x dx from c to t to c as t approaches negative infinity plus the limit of the integral of f of x dx from c to t as t approaches positive infinity. Now, c here is any interior point, okay, of the function f. Okay, so we just need to check or identify any point on the function f. Okay, make sure that it will easily solve the problem. So, para mas maintindihan, let's try to solve the first example here. Okay, so we have the integral of 1 over 1 plus x squared dx from negative infinity to positive infinity. We can separate this one by the integral of 1 over 1 plus x squared dx from negative infinity to, so let's choose one interior point of this, of the domain of this function. So let's choose 0 kasi mas madali pag 0 lang, diba? Next, plus the integral of 1 over 1 plus x squared dx from 0 to positive infinity. Okay, so applying case 1 and case 2, so we have the limit of the integral of 1 over 1 plus x squared dx from t to 0. So we replaced negative infinity by t, and that is approaching negative infinity, plus the limit of the integral of 1 over 1 plus x squared dx from 0 to t as t approaches positive infinity. So let's solve the following limits or the given limits here separately. So the first one, let's try this. So first is yung integral muna. Okay, we know that the integral of 1 over 1 plus x squared dx is just arctan. So this is now the limit of the integral of 1 over 1 plus x squared dx from t to 0 as t approaches negative infinity is equal to, so this is just the limit of the integral is just arctan, so that is arctan of x from t to 0 as t approaches negative infinity. Okay, so from that, this is just equal to the limit of arctan of 0 minus arctan of t as t approaches negative infinity. Now, take note that arctan of 0 is just 0. So therefore, we have arctan of t. So the limit of this one as t approaches negative infinity. So observe, if you can imagine the graph of arctan. If it goes to negative infinity, then the value of the function will approach to negative pi over 2. Okay, so para makita natin, let's have Desmos here. So let's input the function y equal to arctan of x. Okay, so as you can see here, yan, as your value of t or your domain approaches negative infinity, the value of the function here approaches negative pi over 2. Okay, so ayan. So the limit is equal to negative pi over 2. Okay, same sa kabila, we have the second limit, that is the limit of the integral of 1 over 1 plus x squared dx from 0 to t as t approaches positive infinity. This is just equal to the limit of arctan of x from 0 to t as t approaches positive infinity. So from that, we have the limit of arctan of t minus arctan of 0 as t approaches positive infinity. Again, arctan of 0 is just 0, and arctan of positive infinity, again, if your t approaches positive infinity, the value of the function will approach to positive pi over 2. Para makita, let's go back to our graph earlier. So as your domain approaches positive infinity, look at the graph will approach to positive pi over 2. Okay, so from that, we now have the values of the limits. So substituting, so the limit as t approaches negative infinity is negative pi over 2, plus the second limit is positive pi over 2. Therefore, the integral is equal to 0, and the integral is convergent. It converges to 0. Okay, so let's try the second example here. Okay, so same lang ang gagawin natin. So this is just equal to the integral of x e raised to x squared dx from negative infinity to 0. So again, I will choose 0 plus the integral of x e raised to x squared dx, okay, from 0 to positive infinity. So from that, this is now equal to the limit of the integral of x e raised to x squared dx from t to 0 as t approaches negative infinity, plus the integral of x e raised to x squared dx from 0 to t. Okay, again, this is the limit as t approaches positive infinity. Okay, so from that, let us first solve the integral. So I will first solve muna the indefinite integral. Okay, kasi I think we will use substitution here. So using indefinite integral muna, integral of x e raised to x squared dx. So we let u be equal to x squared. So this is by u substitution. So du is equal to 2x dx. That means that du over 2 is equal to x dx. So from that, we have x dx here. So this is just equal to the integral of e raised to x squared is u, and x dx is just du over 2. Okay, so we have 1/2 e raised to u plus c, or that is 1/2 e raised to x squared plus c. Okay, so from that, applying this result to evaluate the limit, so first we have the limit of the integral of x e raised to x squared dx from t to 0 as t approaches negative infinity. That is just equal to the limit of 1/2 e raised to x squared evaluated from t to 0 as t approaches negative infinity. So from that, we now have, this is 1/2 of the limit of e raised to, substitute, so x will become 0, so you have 0 square minus e to the t square as t approaches negative infinity. Okay, so from that, so this is just 1, so we have 1/2 of the limit of 1 minus e raised to t squared as t approaches negative infinity. So if we will substitute negative infinity to t squared here, so that is negative infinity squared, so that is positive infinity. So therefore, this will approach to positive infinity. So therefore, we have 1/2 the limit of, so no, we don't no longer have limit. So that is 1/2 times 1 minus, again, this will approach to infinity. Okay, and 1 minus infinity, that is infinity, therefore, and multiply it by 1/2, so this is negative infinity. So this limit diverges to negative infinity. So I think this alone will answer the problem. Divergent na siya kasi divergent na yung isang term. So let's try to solve the other term para makita lang natin. So the second term, ito, so the second asterisk, so we have the limit of the integral of x e raised to x squared dx from 0 to t as t approaches positive infinity. So this is now the limit of, same lang, 1/2 of e raised to x squared evaluated from 0 to t as t approaches positive infinity, and that is 1/2 of the limit of e raised to t squared minus e raised to 0 squared, okay, as t approaches positive infinity. And from that, this is now 1/2 of the limit of e raised to t squared minus 1 as t approaches positive infinity. So if we will substitute positive infinity here, this will approach to positive infinity. So we have 1/2, then infinity minus 1, and that is just positive infinity. And again, this is divergent. Okay, so therefore, this one here is divergent. Okay, so by the way, if ma-confuse kayo, kasi pwedeng ito, that is negative infinity plus this one positive infinity, this is not equal to 0 because we don't know the real value of infinity. It could be that this one is bigger, so that will have a negative answer, and this one here, if this is bigger, then you will have a positive answer. So we don't know kung sino yung mas malaki sa kanilang dalawa. So therefore, this will not equate to 0. So that's why you automatically answer here divergent. Okay, I hope that is clear.